A new extremely reactive chemical has been discovered in our Earth's atmosphere. Millions of tons of the chemical type can form in the atmosphere every year. Millions of tons of a class of extremely reactive chemical called hydrotrioxides can linger in the atmosphere for several hours, according to a new study, which could have implications for human health and the global climate as well. The chemicals interact with other compounds extremely quickly, and their presence means that chemists will have to rethink just how processes in the atmosphere occur. It's long been thought that hydrotrioxides, which are chemical compounds that contain one hydrogen atom and three oxygen atoms, were too unstable to last long under atmospheric conditions. But the new research shows instead that hydrotrioxides are a regular product of many common chemical reactions, and that they can stay stable enough to react with other compounds in the atmosphere. Henrik Grun-Jargard, University of Copenhagen chemist, said we showed that the lifetime of one of them was at least 20 minutes, so that's long enough for them to do stuff in the atmosphere, he said. Jargard is one of the authors of a new study on hydrotrioxide formation in the atmosphere. It was published a few days ago, May 26, in the journal Science. The discovery does not mean that something new is happening in the atmosphere. Rather, it seems that hydrotrioxides have always formed there, but the new study is the first time that the existence of these ultra-reactive chemicals in the atmosphere has been verified. We can now show through direct observation that these compounds actually form in the atmosphere, that they are surprisingly stable, and that they are formed from almost all chemical compounds. This is what University of Copenhagen doctoral student Jing Chen, second author of the study, said in a statement, saying all speculation must now be put to rest. Powerful oxidants. Hydrotrioxides are a type of hydrogen polyoxide. Water is the simplest and most common hydrogen polyoxide with two hydrogen atoms and one oxygen atom, or H2O as we know it. Another hydrogen polyoxide is hydrogen peroxide, which has two oxygen atoms, H2O2, and commonly used as bleach or disinfectant. The extra oxygen atom also makes many peroxides extremely flammable, and they are sometimes used as a component of rocket fuels. Hydrotrioxides are strange further, as they have three oxygen atoms attached to each other, which makes them even more reactive than peroxides. They're written chemically as ROOH, where R is any bonded group, such as carbon group. But while it's known that peroxides can form from chemical reactions in the atmosphere, it was not known before now that hydrotrioxides can also form there, albeit from a relatively short time before they decompose into less reactive chemicals. In the new study, the researchers estimate that about 11 million tons, or 10 million metric tons, of hydrotrioxides form in the atmosphere every year as a product of one of the most common reactions, the oxidation of isoprene, a substance produced by many plants and animals, and which is the main component of natural rubber, by the way. The researchers estimate that about 1% of isoprene released into the atmosphere forms hydrotrioxides, and that they are produced from these reactions in very low concentrations, about 10 million hydrotrioxide molecules in a cubic centimeter of the atmosphere, which is only a very faint trace. We are super happy that we're able to show that hydrotrioxides are there and that they are living long enough to be most likely important in the atmosphere. Study lead author Thorsten Berndt, an atmospheric chemist in the Leibniz Institute for Tropospheric Research, TROPOS for short, in Leipzig, Germany, told Life Science. Atmospheric experiments. Berndt led the research laboratory experiments at TROPOS to discover if hydrotrioxides were in fact produced by chemical reactions in the atmosphere, while the University of Copenhagen team studied the theoretical aspects of how hydrotrioxides form. Berndt and his colleagues used very sensitive mass spectrometry to detect the ultra-reactive hydrotrioxides, a technique that can determine the molecular weight of chemicals to find out what atoms they consist of. The reactions to make the hydrotrioxides took place in the TROPICS free jet flow system, which creates a flow of air unobstructed by solid boundaries. And the study also used the results of experiments in an atmospheric chamber at the California Institute of Technology at Pasadena, Caltech. Now that their research has confirmed that hydrotrioxides are formed by common chemical reactions in the atmosphere, the scientists will next investigate how the compounds might affect human health and the environment during the minutes or hours of activity before the compounds decompose, Burt said. He said, from the knowledge of organic chemistry, we can expect that hydrotrioxides will act as an oxidant in the atmosphere. He said it's also possible that hydrotrioxides could have an effect when our lungs breathe in air that contains them in very low concentrations, but this is all very speculative at the moment, he said. Burns said hydrotrioxides could also penetrate atmospheric aerosols, very fine solid particles or liquid droplets suspended in the atmosphere, such as the ash from volcanic eruptions or the soot from large fires, and they may initiate chemical reactions there, but experimental investigations on that are very challenging. He said it's a lot to do. This is originally published on Live Science by Tom Metcalf. Please leave your comments. Thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.